Okay, so we're going to be working today completely with distance formula. Distance equals rate times time. I am going to be using a chart to organize your information. That's up to you. I think that once you see me do it, you'll want to do that. Okay? I'm going to start with rate, time, and then distance. The distance box, what I mean by this, the distance box is always, I can't emphasize that word enough, is always the rate and time boxes multiplied. So when you have the distance box on that chart, you don't get that information from the problem. That always comes from what you have already placed in the rate and time boxes. Okay? Once you complete this little chart that we're going to make, you're going to decide, is this a problem where the distance equals the distance, or is this a problem that the distance plus the distance equals the total distance? Okay, so you're going to have to decide that. Let me give you some scenarios of each of those kinds. A distance equals distance would be like if I said, Natalie and Josh, I want you to start at this end of the hallway, and I want you to walk, to go all the way down to the STEM lab, and Natalie, I want you to run, Josh, I want you to walk. Okay? Their rates are going to be different, their times are going to be different, but their distances are the same, because they went from one end of the hall to the other end of the hall. Their distances match each other. If I just sent Sean to the office to do me a favor. If I told Sean, I want you to run down the office and come back on the same route but walk, that's a round trip. You went somewhere, you came back. The distances are equal to each other. Okay? Now, here's a scenario of a distance plus the distance is a total distance. If I put, I'm going to use a football field just for easy measurement here. If I put people on the goal line, opposite sides of the football field, and I ask one to run and one to walk, and stop when you meet, okay? Their distances are going to be different, each individually, but together, they're going to equal 100 yards. The distance plus the one person plus the distance of the other is going to total 100 yards. So that's going to be a D plus D is total D, okay? Another scenario would be, and you'll see a couple of these, if I'm driving along on the highway at normal speed, but then there's an accident and I get slowed down and then I get to my final destination finally, that's going to be a distance of the first part plus the distance of the second part equals the total distance of the trip. Okay? Now, if they don't give you information about a total distance, it can't be D plus D is total D. Okay, so use a little bit of common sense there. If they don't tell you about the total distance, then you can't use that one. Okay? We should probably talk about time, clock time. And let's see how well you understand clock time. You're never going to put a clock time. Like you're not going to put 8 o'clock in your chart or 7:30 in your chart. You're going to put the amount of time. So we're going to be working with fractions because we're always going to be doing hours, never minutes. Hours. So let's start with the easy one. 30 minutes is how much of an hour? Half. 20 minutes is how much of an hour? A third. 12 minutes is how much of an hour? A fifth. 36 minutes is how much of an hour?
7, 12,
If you just give me a fifth.
6 tenths.
Who said a fifth when I said 12 minutes? Somebody said a fifth.
3/5.
Okay, 3/5. So 12 minutes is 1/5. 12, 12, 12 is 36. That's 3/5. Okay? 45 minutes. Okay, I'm trying to do some other common ones here. So that's how we're going to do it. If you don't know that, you take those amount of minutes over 60, reduce it, and that tells you how much of an hour. Okay? So you're going to have to know that. All right, it says, at 8 a.m., the Smiths left a campground driving at 48 miles per hour. At 8:20, the Garcias left the same campground and followed the same route driving at 60 miles per hour. At what time did they overtake the Smiths? So again, as I told you, these are not going to be just straightforward. They give you the information and you set it up like the ones we've done. You've got a lot of inferring to do on this one, okay? So we have two people. We're always going to be comparing two people, the same person in two different situations, something like that. But always a comparison of two things. Rate, time, distance. So all my charts are going to be set up in this format. If I get, as I'm talking, like I'm pausing now to give you time to write that, but if I get ahead of you, please slow me down, okay? That's important that you're keeping up with me. All right, what have they given us directly? They gave us that the Smiths are driving at 48 miles per hour. That is their rate, 48. And that the Garcias are traveling at 60 miles per hour. That is their rate. If they give you clock times, 8 o'clock, 8:20, but they don't give you a clock end time, okay? This is where your variable is going to come in. I typically let the person or group of people who leaves first be my X. So since the Smiths left first, I'm going to let their time be X. They're going to be traveling for X amount of time. Now, the time on the clock is important though, because the Garcias left 20 minutes later. 20 minutes is how much of an hour? 1/3. Now, if they left later, are they traveling less time or more time? Less. Okay, so this is what I want you to get in your mind, because this is a really common mistake. If you're traveling and leaving later, later is less, and less is subtraction. So they're going to be traveling 1/3 less time, 1/3 of an hour less time. So their travel time is X minus 1/3. Minus. Later is less. Later time, less time. Less is minus. Okay, so again, I don't ever put 8 o'clock. I can't put a time, a clock time in there. If I knew a start and a stop time, yeah, then I could figure it out. If it was, start at 8, they met at 8:20, that's 1/3 of an hour. Jack?
Why can't you put X minus 20?
Minus what?
20.
If you want to, in some questions, it ends up a mess, and you have to convert back, and you have to sometimes multiply by 60 or sometimes divide by 60. So if you always leave it in hours, it works. And it's because you're traveling at miles per hour, but then you're putting your time in minutes, so it doesn't come out the same. Okay? Now, if you changed your rate to miles per minute and then used minutes and then converted it back to hours at the end, you could do that, but I think this is easier. Okay? All right, so what I said at the beginning, where the distance box always equals your rate and time, this is what I mean. Distance is rate times time. 48 times x. And 60 times x minus 1/3. So the distance box is always the product of your rate and time. Then you decide, do I set the Smiths equal to the Garcias, or do I add them and equal a total distance? Now, they didn't give you a total distance. And think about the scenario. Here's the Smiths, they leave the campground, they travel. Here's the Garcias, they leave the campground, they travel. Eventually, they meet. Their distances are equal to each other. So I set the Smiths' distance equal to the Garcias' distance. And I worked this out. I saw. So 48x equals 60x minus 60 times minus 1/3 is minus 20. subtract your 60x, and I have negative 12x equals negative 20, and I divide, and I get a repeating decimal of 1.66666, so I need a fraction. Hopefully you remember how to do that. And I get 5/3. So let's reiterate, remember how to do that on our calculator. If I go my 20 divided by 12, I get a bad decimal. And I go to my green key, y equals, number 4 converts that to a fraction. You can't leave it as 1.666 repeating, okay? Okay, now, what do you do with that answer? Because this is not done. X represents, we go back to our chart, the amount of time that the Smiths traveled when the Garcias met them and took them over. Okay, so let's go to 5/3. 5/3 equals 1 2/3. 1 2/3 hours is the same thing as 1 hour and how many minutes? 40 minutes. So, if the Smiths were traveling for 1 hour and 40 minutes when the Garcias met them, and the Smiths left at 8 o'clock, 1 hour and 40 minutes later is 9:40 a.m. for my final answer. Lots of brain work going on for these questions. And just to assure you, we're not assessing for quite a while. So, yes ma'am.
I just need the calculator thing for you for
Okay, so do you have the repeating decimal on your calculator?
Yes.
Do your 20 divided by 12. Okay, now go to your green key, y equals at the top, and then number 4. And that converts it from a decimal to a fraction. Yeah.
You just put in your calculator, if you go like green key, y equals, and put negative 20 over negative 12, and then is that just,
Sure, yeah. Okay, I know this is a big jump from the kind of questions we've done. So let's see if you have anything you want to ask about it. It might take some sinking in time. Okay, let's look at this next one.